Hello students, today is the 6th day of 7th lesson lenses from science section first. Some more concept we are going to discuss within this lecture. Within that, the first concept is apparent size of an object. See, when you are far away from any tower or a building, you are observing or the building is appear to you very smaller. But as you are moving towards that building, that means the distance in between building and observer starts to decrease. The building will start to appear little bigger and bigger. What is the relation within that? Why it is going to happen? All this we are going to make it clear within this point. See, apparent size of an object. For understanding, we are going to consider two objects which are of exactly same size. Here, the first object is AB and second object is PQ. Purposefully, we have considered these both objects are of same height. That means two objects are of same height. That is, height of object AB and height of object PQ is same. And we are observing that both the objects from point O. So this diagram or figure indicates the eye. Now see, while observing the first one, that is first we are discussing this object. This object is AB. This is a horizontal line. But when we focus on the line which is reaching to eye from the top, this is the incident ray we are getting towards the eye, and this is from the base of that object. So because of these 2 points, that is the upper point and lower point of an object, one angle is subtended at eye. So this angle is an angle subtended by object AB. See here. So we are going to denote one point here. So this angle we are considering as alpha. So what is angle alpha? Angle alpha is an angle subtended by object AB. This one is an angle AB. Both are incident ray. One is from the top and one is from the base. And it is making an angle with an eye or at eye. So angle AOB major of alpha is an angle subtended by object AB. Now one more is there. Now when we focus on object PQ, it is also making one angle at point O. So this is that angle. See, but when we consider this angle is little bigger than the previous. So this bigger angle we are considering as a beta. So what is beta? Beta is an angle subtended by object PQ at eye. So when we observe both the angles, though the objects are of same size, angle beta which is made by the object which is PQ is greater than the angle made by object AB. So when we consider this one, measure of angle alpha and measure of angle beta, within this one, which angle is greater? Definitely angle beta is greater. And as angle is greater, definitely the object which making that subtended angle greater, definitely the angle, that apparent size of that object is bigger. So within this one, PQ and AB, which object having the more angle which is subtended at point A or that eye? The angle is beta is more. So beta is the angle made by object PQ, and so here apparent size of object PQ is bigger. Then what is our conclusion? See, the apparent size of an object depend on the angle subtended by the object at an eye. If this angle is greater, object appear greater. If angle is less, then definitely the apparent size of that object is less. So if you conserve or if you apply this information to any point in the nature, you will get the answers. See, a tower is there, you are far away from the tower, and as the distance in between tower and observer is larger, then again angle subtended by the tower is also less, and because of this the tower appeared little smaller. But as you are walking towards the tower, definitely the distance in between the tower and the observer starts to decrease, and the angle subtended by that object at an eye starts to increase, and as that angle is increasing, definitely apparent size starts to increase. So what is the conclusion from this discussion? Angle subtended by that object with eye or at eye is greater, then apparent size is greater, and if that angle is smaller, apparent size also smaller. After this conclusion, as per the textbook, we are having the next point, and that point is uses. Maybe this question will be asked for 2 marks in the examination. Questions like this one: what are the uses of concave lenses? Then few uses are there. As per the state board textbook, we are discussing this only. The first use is medical equipments, scanner and CD player, they generally use laser light, and to perform well, concave lens is used in medical equipment, scanner and CD player. Next to this one, the peephole in the door. Have you observed this one? The concave lenses, while discussing the lenses we have discussed, we are getting always virtual, erect and the smaller objects by the concave lens. If we are going to feed that camera within the door, the person who is standing behind the door appears erect, virtual and smaller, and then by this small camera or by this small lens we can observe the large space outside the door, and we can judge who is in front of door or behind the door, and so we are using this peephole indoor. The third is spectacles. While discussing the defects last grade, we have discussed 3 kind of defects: nearsightedness, farsightedness and presbyopia. So to correct the nearsightedness, we are using that concave lens within the spectacles. And the last use is we are using this one in camera, telescope and the microscope. Here one thing we should consider: generally telescope, microscope and camera are using convex lenses. Generally they are using the convex lenses, but one important fact is that to get good quality images, concave lens is used in front of eyepiece or inside it. See what is meant by that? Generally microscope, telescope works like this one. These are the 2 lenses. They both are convex lenses. If you are observing which are having the same principal axis or parallel principal axis, suppose it is fitted like this one, you are observing that X object, and here we are observing through this camera, that lens. So this is the first lens and this one is the second lens. So the lens which is towards the eye is called as eyepiece. So this concave lens is fitted inside or in front of this eyepiece, by which we are getting good quality images because of these concave lenses. So how many uses are there? There are 4 uses. First, medical equipment, scanner and CD player, which uses laser light. We are using the concave lens within that. Second, the peephole camera. Third is spectacles, generally to correct the nearsightedness, and to get the good quality images we are using this concave lens inside or in front of eyepiece in the camera, telescope and microscope. After discussing the concave lens, we are moving towards the next point, uses of convex lenses. Which are the uses? See, according to state board textbook, we having only 5 uses that can be explained as: convex lenses are used in simple microscope, compound microscope, telescope, optical instrument and spectacles. One by one we are discussing this all uses. Within that one is the first use is simple microscope. While discussing the images formation due to convex lens, we have discussed 6 diagrams. When object is kept at infinity, when object is beyond 2f1, when object is exactly 2f1, like this we have discussed. But see here, when we consider this one as a convex lens, this one is an optical center. Here we having f1, so 2f1. Here is f2 and 2f2. Then when object is kept at or placed at principal focus, that is f1. So we have discussed within that discussion, image is forming what kind of image? Real image, and at infinity, that is of no use. But when object is placed within the focal length, see what is focal length? The distance in between optical center and focus, this is called as focal length. And the object which is within the focal length or in between optical center and focus, then according to the rule of refraction, the one ray is parallel to principal axis. After refraction, it passes through the focus. Then the ray which is passing through the optical center without deviation, it will go, and so these rays are little diverging from one another. They are not meeting each other actually. But if you extend these rays backward or in this direction, they are going to meet at this location. And so here we are getting the image of an object. Then what kind of image we are getting here? See, object is smaller but image is bigger. Then again it is towards left hand side, then it is virtual, and object is also above, perpendicular above the principal axis. Image is also above and perpendicular to the principal axis, so erect. So with the help of convex lens, when object is within the focal length or less than the focal length, then we are getting virtual, bigger and erect objects. That is image of that object. And so by using this property, we can get the virtual image, then bigger image and the erect image, and the lens which is giving that kind of image is called as microscopic lens or magnifying lens. So two questions are there within this one. Explain the microscope or simple microscope and how it will work. See, the convex lens with a small focal length produces virtual, erect and bigger images of an object, just we have explained. And such a lens is called as simple microscope or magnifying glasses or magnifying lenses. So who is using this one? The watch repairer is using to repair the watch. Then again, the person who is dealing with gems or the gemstone, precious stones, they are testing that stone by magnifying it, by observing little larger than the real appearance. So for testing the precious gems and the finding their defects, we are using the simple microscope or the convex lens we are using. So this is the first, the use of convex lens as a simple microscope. Now